General characteristics of compounds of alkali metals. All common compounds are ionic in nature. First, oxides and hydroxides. Oxides and hydroxide. Alkali metals, when burnt in air, form different type of oxides. With limited oxygen, they form normal oxides, that is M2O. Okay, so 4M plus O2 gives 2M2O. This is the normal oxide. So, limited oxygen they form normal oxides or monoxides. So, this M represents lithium, sodium, potassium, rubidium, cesium, etc. When heated with excess of air, lithium forms lithium monoxide and lithium peroxide, Li2O2, with excess of oxygen. Okay, that is oxides or peroxide. Sodium forms sodium peroxide or superoxide. Sodium superoxide will be obtained. Higher cations, that is large cations, potassium, rubidium, cesium, these are large cations, they form superoxides only, that is MO2. Okay, so these are the different reactions with oxygen. Next, temperature required decreases down the group. Okay, then what about the stability? Stability of peroxide or superoxide increases down the group. Okay, down the group, the stability of superoxides increases because larger the size of the cations, they become more stable. Okay, next, what about their color? Oxides and hydroxides. They are colorless when pure, but superoxides are colorless in pure state. Okay, so superoxides are yellow or orange. Okay, they are yellow or orange. And these peroxides are diamagnetic and superoxides are paramagnetic. Okay, superoxides are paramagnetic and peroxides are diamagnetic. Superoxides are paramagnetic because one unpaired electron is present in pi star 2b orbital. Okay. Next, these oxides dissolve readily with water and form hydroxides, and large amount of heat is evolved. Okay. That is M2O, oxide on reaction with H2O. Okay. Hydroxide is obtained, that is 2M plus 2OH minus, and heat is liberated. Okay. First, normal oxide. Next, in the case of M2O2, M2O2 is peroxide. With water, what happens? They form M plus ion and hydroxide are obtained and H2O2 is liberated. That is 2M plus 2OH minus hydroxide, and H2O2 is obtained. What about in the case of MO2? MO2 plus water on reaction with, that is MO2 is superoxide on reaction with water. 2M plus, then hydroxide, then H2O2 and oxygen is liberated. H2O2 plus O2. Okay, these are the different reactions of oxides on reaction with water form hydroxide. Different oxides form hydroxides. Okay, then higher oxides are good oxidizing agent, that is Na2O2. Na2O2 is a good oxidizing agent. Good oxidizing agent in inorganic chemistry. It is used as a good oxidizing agent. Next, what about the properties of hydroxides? Hydroxides are white crystalline solid and they are strong bases. Okay, hydroxides are strong bases. Okay, they are strong bases. Okay, and their basicity increases down the group. Okay, that is LiOH. Then next, NaOH, KOH, RbOH, then cesium hydroxide. Here in this case, down the group, the basicity increases. Okay, alkali metal hydroxide freely soluble in water and is accompanied by the evolution of large amount of heat due to their intense hydration. They are hydrated. Okay, so this alkali metal hydroxide soluble in water and it is accompanied by the evolution of large amount of heat. So basicity increases down the group. Okay, increases down. These are the this much about oxides and hydroxide. Halides. Alkali metals form metal halides with halogens and they are ionic, then colorless, crystalline solids and have high melting point, and the reaction will be 2m plus x2 gives 2mx. Okay, and the order of reactivity will be fluorine more reactive, chlorine, bromine and iodine. Okay, this will be the order of reactivity. And then halides can also be prepared when appropriate oxide, hydroxides or carbonates when reaction with aqueous HX, that is hydrogen halide. All halides have high negative enthalpy of formation. Okay, that is delta HF minus value is high in the case of all halides. But in the case of fluorides, they are less negative down the group. Okay, less negative down the group. But in the case of chlorides, bromides and iodides, they are more negative down the group. Okay, more negative down the group. And the melting point and boiling point will be in the order melting point and boiling point. F2, Cl2, Br2. This will be the order of melting point and boiling point. Okay. Next, all halides except lithium fluoride are freely soluble in water. This is because lithium fluoride, lithium plus and fluoride ion, both Li plus and F minus ion are smaller in size, and due to this there are greater force of attraction between them and they have high lattice enthalpy. Okay. So they are less soluble. Okay, all the other halides are freely soluble, and the case of CSI, cesium iodide, they have low solubility. This is because in the case of cation and anion, they are larger in size and they have smaller hydration enthalpy. Because both are having bigger in size, large cation and large anion. So their hydration enthalpy will be less. So they are less soluble. Then lithium halides. In the case of lithium halides, they are covalent in nature, but all the other halides are ionic. lithium halides are covalent in nature because Li plus ion is smaller in size and they have high polarizing power, and halides are bigger in size. So the electron cloud will shift more towards halides and they are covalent in nature. And in the case of lithium iodide, iodine is bigger in size compared to all the other halides. Okay, so they are more covalent in nature. So lithium iodide is more covalent in nature. Okay, then next, lithium chloride is soluble in pyridine. Lithium chloride is soluble in pyridine. Okay. Salts of oxo acids. What is meant by oxo acid? Example, let us take carbonic acid. Carbonic acid is H2CO3. Okay, so this will be like this. Okay, like this. So this contains two OH ions. Okay, so oxo acids are acids in which the acidic proton, that is this hydrogen, that is this is acidic proton. Acidic proton is on the hydroxyl group with an oxo group. Oxo group is attached to the same atom. Okay, these types of acids are called as oxo acids, that is in which the acidic group is on the OH group. Okay, acidic hydrogen is on the, or acidic proton is on the OH group. At the same time, an oxo group is attached to the same atom. Okay, such acids are called as oxo acids. Another example is H2SO4, that is like this. Okay, so acidic proton in the OH and oxo group is attached to the same atom. Okay, this type of compounds are called as oxo acids, and alkali metal forms salts with oxo acids. Okay, they form salts with oxo acids, and carbonates and bicarbonates are stable towards heat. Next, what about carbonates? M2CO3 and NMHCO3. These are carbonates and bicarbonates. These carbonates and bicarbonates are stable towards heat. Okay, but in the case of lithium carbonate, Li2CO3, lithium carbonate is less stable and it decomposes readily on heating. This is because lithium is so small and it polarizes a large size CO3. CO3 2 minus is having larger size, and Li plus is smaller in size. So due to this, when heat is applied, lithium carbonates gets dissociated into LiO2 plus CO2. Okay, Li2O plus CO2. Monoxide plus lithium monoxide and CO2, the carbon dioxide gas is evolved. Okay, due to the smaller size of lithium ion. As the electropositive character, we know electropositive character increases down the group in the alkali metals. So the stability of carbonates and bicarbonates increases down the group. Stability of carbonates and bicarbonates increases down the group. Because the electropositive character increases down the group. Okay.